This is Algebra 1, Semester 2, and the unit is Quadratics. It's the third unit. It's the 12th lesson, Vertex and Line of Symmetry Practice. It's on creatormath.com under the Algebra tab. You might have to put in creatormath.weebly.com to find it in Google. Copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages. We'll pull up the notes in a second just so you can see where they are. And again, it's on creatormath.com under the Algebra tab. What is the vertex coordinate location of the parabola shown before? Shown below. Sorry. Try to read here. Shown below. Okay, so if we look at this parabola, they're giving us a graph. This can be done any number of ways. I can do it visually, though, right off the bat. All right. This is a negative 35. I see the parabola right here, and here's the vertex. So this is negative 30. 1, 2, 3, 4, 5. Each unit is 1. This is negative 36. So y is negative 36. And it looks like x is 1, 2, 3. So negative 3 on the x, negative 36 on the y. That's this right here. Right? And therefore what they're saying is this line of symmetry. Therefore the line of symmetry is at x equals minus 3. So that what happens is the line of symmetry divides the parabola right in half and goes right up through here. It's like a center line of the thing. I'm trying to draw a center line, which is the kind of dash you've got here. So this is called the line of symmetry. Remember, symmetry means if you folded this side of the shape over onto this side, it would exactly line up. That's what symmetry is, right? So line of symmetry of a parabola runs straight through the x value of the vertex location. This point here is called a vertex, V-E-R-T-E-X. And on that note, let's quickly go to this is creatormath.weebly.com, where you find all of these notes and these videos and etc. instructions for the comp book. Remember, the comp book instructions are on this home page. You can find them down here. We're going to go straight over to algebra. We're going to pass by the vocab and go to semester 2. We're looking for the right unit, exponents and polynomials, modeling two-variable data, quadratics. And we're all the way down here on number 12. This is lesson 12, vertex and line symmetry. Open up notes here, and by the way, it goes on page 77, 78 of your comp book. Please follow whatever table of contents you have when you're watching this. It's probably going to be different. Notes. Open that up. This is what goes on those pages of your comp book. It loaded for me right there. And this explains center line or line of symmetry. See it right there? It's explaining the whole thing. It's explaining how to find the center line or line of symmetry right here. They're plugging in the location. To find the y location, we use the, oh, interesting, okay. And I don't know if we're going to have to do that on this assignment or not. We might actually just be able to look at the, the visual. Let's see, preloading, key points. We can also use desmos.com, it's telling us right here, so we can graph these. We can use any number of things. And here's the x location of the line of symmetry. Formula x equals minus b over 2a. We can also use that to find out what we're dealing with here, right? And that's if given an equation. Let's see if we're going to be given that throughout this assignment. All right, find the vertex location of the parabola shown. So again, it's just visual. If this is 2, 4, 6, 8, 10, then this has got to be 2, 4, 6, 7. So I'm 7 on the x. And actually, let's see. If this is 2, 4, 6, 8, 10, then this is 2. This has got to be down 1. So I think it's minus 1. I think it's 7 minus 1. Good. And that means the line of symmetry is at x equals 7. It would go right through here at x equals 7 all the way up. And up it would go, splitting that parabola right in half so that if you fold it over one side, it'd be on the other. I think what this lesson might be trying to get through my mind is that every time I have an x location of the vertex, I now know the location of the line of symmetry because x equals 7. Let's see if that's true on the next one. All right, find the vertex again. Well, it doesn't look like I'm calculating it, you guys. I'm counting it each time. 2, 4, 6, 8, 10. So this has got to be at 7 on the x. So I already know that x is going to be 7 for the line of symmetry. And then it looks like minus 2, 4, so minus 4. So I'd be circling this one. And remember, for me, they're always the first answer. For you, it's going to present them randomly. And I'm just going straight to the vertex on these and looking at its location. This looks like, let's see here, this is minus 50, minus 60 to 4. So on the y, it's minus 64, comma. On the x, looks like a negative. If this is 2, this has got to be negative 1. So negative 1, negative 64. Therefore, I know the line of symmetry is going to be x equals negative 1, x equals negative 1. And the line of symmetry passes right through there. And are they just going to beat me to death with this same type of problem? Yep. All right. Well, this looks like it's on the x-axis here. Is it on the x-axis? Yes, because this is 0. So this is on the x-axis. So in terms of what y equals, y is going to be 0. And then it looks like, look, this is 20. So this has got to be 5, 10, 15, 20. I have to adjust to the scale. So this is going to be 5, 10. Yeah, and it is off the line. I would have to guess negative 11, I guess. I guess is what I'm looking at. And therefore x equals 11 for the vertex. I can't use Desmos because they're not giving me the equation of these parabolas. So they are asking me to do all this visually. Let's just guess that this is 20, this is 10. I'm guessing positive 11. And I'm guessing it's 0. So therefore, the line of symmetry has got to be at x equals 11. Well, they gave me a lot of problems, but they're easy, and they're repetitive. Well, look how far down this is. Minus 120 is right here, and it's below that. So out of my answer choices, there's only one that's even close. It's this minus 121, comma, and it's right on the y-axis. So this has got to be 0 here. In terms of x location, it's right on the y-axis. That makes x equal to 0. That means the location of the line of symmetry is x equal to 0. Minus 6, 0, and therefore x equals minus 6. Minus 4, so it's got to be minus 4 here for the x. Y looks like it's down, if this is 1, 2, 3, 4, 5, which you can't see. 1, 2, 3, 4, 5, each unit is 1, so it's here, it's negative 1, so negative 1, negative 4, negative 1, and therefore the line of symmetry is at x equals negative 4. So kind of just getting me to practice over and over and over that the line of symmetry is equal to the x value of the vertex location. Here's the vertex. What am I out here? Let's see. 1, 2, 3, 4, 5. 6. How about 6.5? Is that one of them? Let's see. 5. 6, 7, 8, 9, 10. Well, I say that the x value is 6.5 right here. If we're just going graphically, I don't have anything else to calculate it from. Just looking graphically. If this is 1, 2, 3, 4, 5. Right? Here's 5. This is 6, and it's right in between 6 and 7, so 6.5. 6.5. And then if this is 0, and this is 5, then I'm counting down 1, 2 down. Negative 2. So I'm circling this one, you guys, but I'm definitely going back and fixing this. I'll check this one. This looks for sure like it's 6.5 comma negative 2, and therefore this thing would be at 6.5, right? Again, I'm a little bit ahead of you guys, so I will fix it before you get to it, right? Negative 60, negative 50, so this is 2, 4, 6, 8, 10, 2, 4. So I think y is negative 64, and I think x is over this way. What's my scale up here? Sometimes you can have a different scale for x and y. It looks like it's 2, 4, 6, 8, 10. So each unit is 2. So this has got to be negative 1. Negative 1, negative 64? Check. And therefore x is at negative 1? Check. And that's the x value of the vertex location, which defines the line of symmetry. So 2, 4 again, so y is minus 64. X, it looks like it's here, 1. This is the reverse of the 1 I just did. That's why my brain is thinking so quickly here in terms of it's 1 to the right and 64 down. This is a negative, and therefore the line of symmetry is at x equal to 1. Oh, interesting. Okay, here we go. Using x equals negative b divided by 2a, what is the x value of the vertex and the location of the line of symmetry of this function? This is the first calculation one we've got. Well, let's remember that for a standard form quadratic, it's ax squared plus bx plus c. I am going to give you some notes on this without looking back at the notes. Any value, any coefficient in front of the x squared is going to be a, any one in front of the x is going to be b, and any in front of this one. So we have x squared, here's our actual example, minus 2x minus 63. So what do we have? We have a equals 1, because there must be a 1 right here. We have b equal to negative 2, because that's what's got to be in this place to produce this. And we have c right here, tag along, equal to negative 63. That's what we've got. This then, for a vertex, is x location equals negative. I'm going to change it to caps since that's what I'm using here. Negative b over divided by 2 times a. That means x is equal to negative b. So negative, negative 2. b is negative 2, and there's a negative in this setup, this formulation here. 2 times a. 2 times 1 equals, negative times negative is positive, so you've got a 2. 2 times 1 is 2. This equals 1. So our x location is 1. X equals 1. And if the x location is 1, then that is the location of the line of symmetry, because that's what we learned in the prior ones. Here we go again. Let's go a little bit quicker. We need a, b, and c. A equals, b equals, and c equals. A has got to be 1. B is negative 13. C is 40. We know that x equals negative b over 2a. So x equals negative b, so negative, again a negative, negative 13 over 2 times a, which is 1. So the x location is, negative negative is positive, 13 over 2. Oh, 13 over 2, or 6.5. You know what? That looks a lot like the problem we did. Remember it was 6.5? I'm going to go back and look at that one too. So they're giving us a couple more of these. Let's go as quickly as we can. A equals 1. B equals plus 8, right here. C equals 15, and it's a positive. X location equals negative b over 2a, which equals negative 8 over 2 times 1, which equals negative 8 over 2, and 8 divided by 2 is 4, or negative 4. So the x location is negative 4. That's also going to be the location of the line of symmetry. Okay, here we go again. A equals, looks like 1. B equals positive 2. C equals negative 63. Getting a little bit messy here. Negative b over 2a equals negative b, which is negative 2 in this case, over 2 times 1, because a is 1, which equals negative 2 over 2 is 1, so negative 1. Aww. That is the location of the x value of the vertex, and it is also the location of the line of symmetry. All right, make sure you're on the right lesson and the right unit, and you're in the right place on the website so you can find the notes and the video for this. It's Algebra 1, It's semester 2. It's under the Quadratics unit, which is the 3rd unit, and it's the 12th lesson, Vertex and Line of Symmetry, on creatormath.com under the Algebra tab. You might have to type in creatormath.weebly.com. Hope this helps.